Okay, welcome everybody. My name is Colin Doyle. I'm an engineer with Roadstone and I'm a member of Engineers Ireland South East Committee. Today we're going to have a presentation by Ciaran Collier on asphalt industry update and the road ahead, a supplier's perspective from Roadstone Ltd. Ciaran is a Roadstone Ltd employee. He's worked in the asphalt industry for over 30 years. He's a DIT graduate, originally a degree in applied physics, and he's recently finished a Master's in Science and Engineering in 2018. Ciaran's had a number of roles within Roadstone. He was a senior lab laboratory technician before going through a number of QC and R&D roles to end up what he is today, which is the National Asphalt Technical Manager for the country. He's the current chairman of the Irish branch of the IAT. And he also has he's on several national committees, including the NSCI's Asphalt Working Group. Without any further ado, I'll let Ciaran start his presentation. Thank you.
Okay, thanks very much, Colin. Hello, everybody. Thank you for staying on this evening to go through this presentation. And sure, look, we'll try and move through it as quickly as possible. Really, the overview of what I'm looking at are the following. I'm going to touch on these points because a lot of these have a good amount of detail behind them that you could do individual presentations on them all. So we'll just cover these main basic points and try and give as much relevant information to yourselves as possible in that time that we have this evening. Okay, so quickly on to standards and specifications. In Ireland, we're producing our asphalt materials to ISEM 13108. The 2006 version is currently in use. If you go looking online, you'll find that there's a 2016 version. That has never been formally ratified by the European bodies in place. It was published, but never, I suppose, officially published in the Journal of the European Union, which it should have if it was to become official. So we're still operating to the 2006 version, basically. Test standards are to the ISEN 12697 parts. There's over 50 tests there now at the moment. And of course, other standards that we're operating in Ireland are the NSCI's SR28. We'll go through that. That's a very good document for people to understand and know about. And also you've got the construction product regulations that we're all operating to in Ireland for asphalt materials. With the CPR requirements, all bituminous materials are to be CE marked to System 2+. That's a third party, such as the NSA comes in and audits an asphalt producer, make sure that they're doing everything in line with the standards that are required for that product. Again, asphalt materials are a harmonized standard, so you have to produce a CE mark. Concrete, in another case, isn't a harmonized standard, so you don't produce CE marks and DOPs for those. So it's quite a different thing. In place in your company, in your actual production facility, you have your factory production control set up, you have a quality management system, and you're providing information relating to type tests and DOPs. They're very important things for the customers to actually take, and we'll go through parts of that further in this presentation. So the actual standards that we're producing to, the ISE 13108, Part 1 is for asphalt concrete. This is the old macadam specification. And you can see there just a little snapshot trying to give you an example of what the material looks like or how it's made up. It's a dense graded material usually. You do have open and medium versions of it, but it's also considered continuously graded. So the material doesn't have a sharp change in gradation. Now that does change up when you have open and medium grades, but the fundamentals of the material will be that it's continuously graded. Your hot rolled asphalt, as you see there, the image of that, you have a lot of fines and then you have a certain amount of coarse aggregate. That amount of fines in it means that it doesn't have a texture of any nature, because it's so fine, it just produces a very flat surface. So in order to get that, you have those black chips on top, which is just pre-coated chippings going in. HRA would be very popular material in Ireland over the last 50 years. But what's taken over from it really on the national road type works and different projects will be the stone mastic asphalt. To Part 5, SMA is a hugely popular mix. It's got a stone skeleton in the mix, so you can see it's quite a coarser grade material, and that interlocks together and gives you a very high performing material for rutting, for deformation, for also you're using good binders with it to give a good performance for water sensitivity. Your porous asphalt below, we'll touch on porous asphalt as well this evening for sustainable products. And you can see that it's a more open material. It has interconnecting voids, so water can actually get down through it. And we'll display that later on with a short video that I have on a particular product that we produce. Outside of that, then you've got reclaimed asphalt. To Part 8, that's the materials that we might reuse in our asphalt plants. And we'll go through a little bit of that as well, Stephen, because we're touching on sustainability. Okay. In our actual production facilities, we run type testing on our products in order to produce them correctly to the European standards. We also have our factory production control system, which is to Part 21. And those two are very important documents to show compliance of our products on an ongoing basis at our plants. On site itself now, there's a number of documents that people might use to show compliance with what is required by the client. So you have a document BS 594987, and that's a very good document. People use it for certain aspects, but again, it was sort of put together last minute because the European standards don't really deal with transport and lay and compaction materials. You have here in Ireland, we don't have a version of that currently, but we are working on our own version, which is ISA 44, and hopefully that will be coming out in 2022. It'll definitely be going out for a review in 2022. And people will get to comment on it. Now, we'll go through a document here that we came up with previously, prior to IS 844, and we looked at why people weren't using some of these documents as well as they could. So really, we've gone back to basics on some of them and actually introduced a number of different things that made them more user-friendly. So we mentioned SR28, that's the standard recommendation for the use of the 13108 series in Ireland. It's very important because it's directly linked to the 13108. And in Ireland, what we've done is we've actually broken down, I suppose, the basics of what is the end uses of these materials. Typically in Ireland, you know, what should the mix design parameters be for the mixes in Ireland, composition and gradings of these, you know, conflicting requirements, just highlighting different things that, you know, we shouldn't be using these materials or expecting certain performance categories of these materials. If we choose to use them. And again, we've got the mixture end use and pre-coated chippings, which is a specialist mix in Ireland. Now, the reason why I've shown SR28, a lot of people maybe on this talk this evening aren't as familiar with the asphalt industry as they'd like to be. And SR28 is a very good document for someone to go and review and start to refer to with the types of materials and the end uses of those. So that's it's a very important document, I think, and a very useful one for people in the industry. So it's one to go and get if you don't have it. Just mention other specifications that are out there at the moment. You've got the likes of TII Series 900. Very important document there on national roads. Again, you might not be using this. This is high performance materials for high speed roads. And you know, you might not need that in the situation you're looking for. But what I would say, back in 2015, TII reviewed what they were doing, overhauled basically the Series 900 and took a different, I suppose, approach to how they wanted to have materials used on their roads as well as how they're designed. So previously you would have looked at a recipe / design type mixes in there. They went down the design / performance route with the new 900 series. So you now have, you know, a good focus on the air voids in materials, how stiff the materials are, what their water sensitivity performance is, you know, what is the rutting performance of these materials as well. So a lot of high performance testing in there. And in fairness, we've been working on it with TII over the years. And what we're looking at now is that really, I suppose that they're maybe going to reissue a new version of the Series 900. Maybe in 2022, I believe that they've been working on it, and I think they're awaiting comments from industry. But really, they're reviewing all these categories and performance levels that they've looked at over the last few years and seeing what they believe they can use going forward. Now, another thing that will be coming out maybe in 2022 is the Irish Analytical Pavement Design Methods, which is again from TII. This is taking, I suppose, the actual performance of materials and designing the most efficient pavement possible for it. And so this is another approach to how to design pavements. The standard design methods at the moment nearly always bring you back to a minimum depth of a pavement, not really mattering how much traffic is going across it. So you never really get away from a sort of a standard pavement depth. The new method or this new design tool that TII have produced, from what we've been told, will be able to assess the materials based on the performance categories and therefore give an appropriate layer depth for that material, for its strength characteristics, stiffness characteristics, and water sensitivity, and a new test, which is called the fatigue test. That fatigue test is a very new thing to Ireland, and we have very little experience of it to date. It'll be one that the industry will have to catch up on, and it is a case that the IEPDM is looking for a hand-in-hand approach between the producer, the designers, and the customer and the contractor to come up with the best solutions for the project at hand. So that'll be an interesting one coming down the line. Again, it may not affect what you're working on, but it'll be something that you'll hear in the industry. Other specifications that you'll see on a regular basis, look, the Department of Transport and the Road Management Office have the orange book and the purple book there, typical uses for those. As I'm the IET chair, I'm going to give it a bit of a plug. We have the surface stressing guidelines for the IET. This is a very useful document. What you'll find is it gives very good information on your constituents, on worked examples of how to design surface stressing, how to install it, and then aftercare of that as well. So it's a very useful document for especially the county council engineers that are out there, and the work that they will be doing on an ongoing basis on their pavements. And outside of that, then you have the likes of the Ministry of Defence type documents. There's a series of these, and again, these are maybe slightly more not in common use across industry in Ireland. It's aimed more at the airports, but they might be documents that you come across every now and again. But they're there, they're in use. Most common ones, of course, will be what we've gone through already. Okay, very, very quickly. So I'm just going to go through, I suppose, the running of an asphalt plant. So what you have here are cold feed aggregates. I think you can see that. Okay. These are hoppers where the aggregates are stored. These go onto a belt and into this, the drying drum here. And this here on the right hand side is a drying drum. And you can see there's lifters and plates and fingers that lift the aggregates and drop them. And this here is a burner, and this is throwing a flame down the full length of this drum, heating and drying the aggregates. And what you have then is that we get the aggregates to the raised temperatures that we need them to. These then enter this lift here. A bucket elevator goes to the top of the tower and then goes into different bins because it's been re-screened. And then down here we have a weigh scales that weighs out each size that we need for a particular recipe, particular mix that goes into the mixer. This is your programmable mixer here. The materials get mixed together with bitumen filler, and then as it discharges, we check the temperature of that, and then it enters a skip car that brings it up to your hot storage over here. And then you have trucks can load out of that. And you also can see here you have control cabin where there's an actual batcher man controlling all this. This isn't an automated system. You would actually have a person operating the plant at all times and checking to see that parameters are being met throughout production. That's a very, very quick overview of how a plant works, how it operates, and hopefully it'll give you a little idea of what goes on. Okay, we're going to touch on now the sustainable end of the asphalt industry and what we're doing currently to sort of make ourselves more sustainable and how we're trying to become, I suppose, a bit greener. So in the most prominent areas of this, you know, we're leading the way with reclaimed asphalt. You have suds asphalt, we'll touch on that, and then there's warm mix asphalt as well. 3 different things to just go through and give you a little bit of information on them. Reuse of asphalt is a very important thing that I suppose we're getting to grips with in Ireland. Reclaimed asphalt, it has its own European standard, ISCM 13108 Part 8. It is 100% recyclable back into new hot mix asphalt materials. By recycling or reusing that reclaimed asphalt, you have the savings on the aggregates that would have to be produced, and of course the transport of those, as well as the bitumen that was being used as well. And so it's a massive part in I suppose making our industry more sustainable is achieving a good level of recycling or reuse of these materials in an appropriate manner. Through this, you know, we're going to have an improved LCA for these products. We're going to reduce our greenhouse gases. Now, in your ton of asphalt, we just did a calculation on your CO2 equivalent kgs per ton, and you know, the two that you're saving on when you're reusing reclaimed asphalt is the aggregate amount and the bitumen amount. You can't recover the mixing, you can't recover the heat nor drying. Those things, you know, they're lost essentially, but you can, because when you use the aggregate and bitumen again appropriately, you will of course regain those, and that's recovering it. Now, it's important to understand how you recover that, and that's through hot mix asphalt, because you're actually activating the bitumen, you're getting used to that bitumen, and so you're roughly recovering about 44% of the CO2 that was used, and is recovered. If people believe that by, well, I'm going to use reclaimed asphalt as, build up road verges, that's recycling. Really, all that you're even getting close to recovering is that 4 kg. You're not getting close to that. You're only making a saving of maybe 8% of that CO2 that could have been saved. It's a minute amount compared to what it is. And of course, we have the hierarchy of recycling there on the left hand side. Can it be prevented? Can you reduce it? Reuse it. And reusing it means back into hot mix materials, back into a similar product again, and giving it that full potential of recovering that carbon. Otherwise, you're talking about this recycling, which is using it as a base aggregate or a base fill. You're not really meeting the potential that's there for the reclaimed asphalt. It's an important thing to give it that opportunity to make that saving. How do we recycle it in the asphalt plant? So you saw a quick overview of the plant. There's two systems really that are in use in Ireland. You have a cold feed system, which is a hopper that feeds directly into that mixer, that pug mill mixer. So as the aggregates come in hot, the wrap comes in cold, and that gets mixed, and moisture is driven off with the elevated temperatures of the aggregates. That steam is taken away, and then the bitumen is added in, and this is all mixed together, and you get your final material. Otherwise, on the right hand side, you have a hot addition system. So you saw that dryer drum that we had for drying the aggregates in the original plant schematic. Well, this has a second dryer drum for drying the wrap, and this comes through the wrap, the drum, reaches an elevated temperature. It's then moved to a hopper right beside the mixer, and then it's used in higher amounts in the mixer. So cold wrap, reclaimed asphalt, I've got 10 to 15% there. I think, you can get as high as 25% at times if your moisture content is low. Your hot wrap system, we've seen levels as high as 80%, and I believe Benninghoven and Amman and a few other asphalt plant producers are talking about 100% recycling in their newer facilities. It's been a big drive in industry across Europe and across the world to optimize the amount of reclaimed asphalt that you can use. The benefits are massive to using it, and again, that recovering of that carbon is such a massive benefit to the industry. When you're using reclaimed asphalt, you really have to have a good knowledge of what the wrap is, where it's come from. As you're using it, you need to be aware of the moisture content in it, binder contents, the properties of the actual wrap, and so that you can design properly a material that will be suitable. Again, you're trying to take out some virgin material, some virgin binder, put back in this wrap binder and the reclaimed aggregates. So you want to be sure that you're getting an equivalent material at the end of this, that you're not giving a lesser material. And that's a preconception sometimes, that when you've recycled or reused reclaimed asphalt, that you're not getting that equivalent material, that you're not getting the same base or binder course that you had previously. That's not the case. When we're designing it, you're designing to have an equivalent material to meet those standards that are in place, so that it is going to give you the same lifespan as you had expected. In Ireland, we're not currently recycling into surface courses. There has been trials carried out recently, I believe, with TII, and they were there a couple of years ago as well. It can be done, but I suppose there's limitations as to what can be done with it at the moment, as it's not within the Series 900. That doesn't mean it can't be done on smaller scale works outside of the TII type works. This is a potential to be used in any type of contract if between the producer and the client an agreement can be made. So another sustainable part of the industry, and I suppose no better time maybe to show this after the storm there over the last few days, is sustainable urban drainage systems. And this is trying to manage water and runoff on your site and not to have it causing flooding in different urban areas. And again, we're constantly building, we're constantly expanding. So we really have to manage this going forward, that, you know, we can all see the effects and what we can do about it now. And there are products there that we can use to help with this on different sites. So we have a DuraFlow porous asphalt. It's a sud system where we have a fully porous pavement. So you'll have a porous surface and binder course on top of a coarse grade of stone that sits on top of a geotextile or a geomembrane of some sort, maybe even a geogrid if it needs it. And what that allows to do is the water to pass through the asphalt layers in situ on that spot, right there where it is, and then stores that water until it can either infiltrate through to the ground beneath, or you can attenuate it away through some pipe system. It's become very popular over the last few years, and we've done a number of large scale works around the country. You can see just a lab compacted specimen there, and the water just flowing through it. The right hand side there is the Carrick Mines Park and Ride. I think we've got that down nearly 10 years at this stage. And we've also got the DAA Red Car Park. That's the overview of the site. I believe it was about 62,000 square meters of permeate-based DuraFlow put in on the site. It was a huge site. We believe it's one of the biggest sud systems in Europe. And it is a fantastic job. We have a short video here to show you. Let's just see if it plays. So what the guy said, where the tractor is, you have standard SMA, which falls to the parking bays, which is all DuraFlow. So on the left hand side, you can see that the water is spreading out. And we'll just fast forward a little bit. 40 seconds in, and you'll just see the water flow is still high, but the water is really dissipating across the parking bays very quickly. The influx of water is very high into the material at that point, and the product can handle it. It's a very, very open material and porous, and the permeability is excellent on it to take this amount of water in and to manage it then in the stone layers beneath. I have to thank Mark and Carol from the DAA for giving me that video. It's a nice video to show just how much water can actually be managed with that system. It's a very good product for that, and again, it's been used in a number of car parks, such as Aldi's and Lidl's. You'll see them all the time, and we've done them in a couple of housing estates at this stage as well. Warm mix asphalt. Warm mix asphalt is, I suppose, something that's quite new to the Irish industry. It's a generic term for, I suppose, the use of either a technology or a type of production technique that allows the producer to reduce the actual mixing temperatures. And this has, I suppose, a couple of different benefits depending on the type of additives that you're using. Now, typical materials are made from 150 to sort of 180 degrees temperature. Your warm mixes are made anywhere sort of up to 100 to 140 degrees is typical. After that, you're going into your half warm mixes or your cold mixes, which typically are emulsion based. This is warm mixes are typically made with standard hot bitumens, but you have those additives that allow different things to happen in the mix. One is that it extends the production temperature envelope and allows the aggregates to be still coated with a reduced mixing temperature, and allows the bitumen to flow and wrap the actual aggregates. And then after that, you have that it actually allows the materials to be transported to site at those lower temperatures, and on site it opens up the compaction envelope, which allows the materials to be compacted on site at a larger range of temperatures. And that's been noted across the world, and it's a common feature, I suppose, in the US and a couple of other countries. One of the other added features was that some don't use it as a warm mix technology. They use it to transport materials a greater distance. and ensure that when they arrive that they'll still be workable, they'll still be compactable. So we've seen that in the likes of Australia and some regions of the US as well. Benefits of warm mix materials, again, that lower production temperature, a decrease in energy consumption. You've got your lower volatile organic compounds. You've got your NOx and SOx emissions. The big benefit that a lot of the additive companies are saying is that because you've reduced the mixing temperatures, you've actually changed the environment within which that you've made the materials, so that the bitumens will age as they're actually being produced, or as they're being made into asphalt materials and bituminous materials, because of those increase in temperatures. So that aging and oxidation of the material doesn't get to happen because you don't have that higher temperature that has been noted before. Because of that, they believe that the materials will actually potentially have a longer life because they haven't had that initial phase of aging, and that they will, outperform standard materials in the long run. Again, I suppose this has been around a long time, but for ourselves in Ireland, we did trials, I suppose, easily 10, 15 years ago, but I suppose they haven't been followed up with, on-site monitoring. And I suppose it's one of these things that, we're catching up on this now, and there's been a number of trials this year to try and, I suppose, get more experience into the industry in Ireland and assess, are these a good potential for us. Of course, with the reduction in energy use, you've got the potential for an improved sustainable product, a reduction in fuel use, a reduction in emissions. All these things add up to, more sustainable products at the end of the day. So in September this year, we carried out a trial in Waterford. We made approximately 140 tons of AC14 surface course, and produced it at a temperature range of approximately 130 to 140 degrees centigrade. When we went to site, we noticed that the product laid as normal as you would see. You don't have steam, you don't have the usual sort of smoke that you might see around the back of the trucks or as the materials are being paved. The paving crew were sort of, a bit, I won't say standoffish, but they were just noting that it did definitely look different, but it laid the same. And in fact, they believe maybe that it had a more closed appearance in the actual pavement in the end. I suppose it's interesting for us that, that this will be a change of mindset, not only in the production end, but also the designer's end and actual the end user's end and the guys installing it. That just because you don't see that steam, you don't see that smoke, it doesn't mean that you're going to change the product, that it's not going to compact as well, that you're not going to achieve a durable material. So it will change. It will take a bit of a change in mindset. The plant data for that day, we analysed to see, what was the fuel use like. So compared to other materials that day in the previous couple of days, we did see about 23% reduction in fuel use at that point in time. And that would match with what we've seen across, I suppose, the industry. They would say, 15 to 25% is what they have noted in the past that can be achieved when using these products. It's very interesting to see that, we landed right where we were, I suppose, told we would be. The warm mix additives, I suppose, could give a bit more information on those. They vary as to their origins. Some are just chemical compounds. Others are byproducts of different productions streams. One is the timber milling that produces an oil that they combine with one or two other products, and then that actually gives it the properties that it can to extend the working windows and compaction windows of the actual asphalt materials. We did take samples from the actual production run of the AC14. And what we found were we got similar air voids for the warm mix materials as we did for the standard materials. No real difference between them. The water sensitivity test that was carried out on both sets, we found were slightly improved for the warm mix materials. And that would be something that in the past we've seen and been told that, you know, this can happen. The warm mix additive, because of its nature, will actually help the bitumens improve their binder adhesion, but also that they get a better coating with the material. And then we've also seen a similar performance for resistance to permanent deformation. That's, I suppose, an interesting thing to see, because again, the aging process that normally would happen with the standard hot mix asphalt would result in maybe a stiffer mix, and that stiffer mix would result in usually a slightly better permanent deformation. But in this occasion, we found that the two of them performed very similar, so no big difference between them. I suppose, yeah, just to maybe note as well that this is a big moving, I suppose, thing at the moment in industry, warm mix asphalt. In the UK at the moment, the Highways Agency have announced, I suppose, over there the last 5 years, they've done a lot of work with the different companies in the UK, different types of projects, and they really went and looked at, you know, the options for warm mix asphalt. And of course, they looked at the different types of warm mix asphalt that are out there. Like I said, there's chemical based ones, there's the ones that are using different oils, there's wax based ones as well, and then there's, you know, ones that use, you know, a sort of a foaming technology where water is sprayed into the mixer and it helps the bitumen expand and coat materials. And so they've gone through a number of different trials, and they've basically decided this year, I think it was only in October, that they announced that, you know, moving forward for them, they expect to have a warm mix option on all their large scale works, that they accept that this is a material that is equivalent, that will perform the same, and that will achieve the lifespan and durability that they require. So that was very interesting to see that happen. And look, that's a big move forward, I suppose, in the UK industry there. For ourselves, I know TII have done trials this year with another company. I believe they've gone very well. They carried out a presentation there to TII recently, through the IAT, sorry, and the performance looked very good of the materials. Again, some more research and a bit more, I suppose, trialing to be done on that. And I'm aware of a trial being carried out in Northern Ireland as well, with the Northern Irish Road Authority, and that again went very well as far as I know. So warm mix asphalt is, I suppose, is available in Ireland. It won't be available everywhere, I suppose. As I'm saying, this is new to a lot of different parts of the country. It will be available from some plants, but I suppose if clients want it, then the producers will have to go and get the pieces of kit and different parts of the plant to make this material available. That trial with Waterford County Council, I have to thank the paving crew on site that day, as well as Anne-Marie Casey from Waterford County Council, for helping to organise it and making the arrangements that we could do it. So we were very grateful for that opportunity with themselves. The last thing that I wanted to really cover was environmental product declarations. This is something that is very, very new to the Irish industry. You might find that there are, if anyone's worked in the UK, that yeah, these are being talked about, and there's some being used, but it is very new to the construction industry in Ireland. There are only a couple of products, I suppose, that have been certified to date. It's not a very easy process to go through to get certification, but it is possible, and we as a company are moving that way, and we would believe that, you know, 2022 we will be getting certification for a large range of our products. It takes a lot of information to get there, but this is the typical, I suppose, indicators that are expected for your declaration there. You know, there's a global warming effect, ozone depletion, and there's the other factors as well. But I suppose in order to see those declarations or to provide those, these are the type of inputs that are needed. You know, a lot of data on the actual raw materials, the fuels, the plant itself, how you use those different parts of the plant, you know, even down to the amount of maintenance that is being carried out in parts. And this isn't something that, you know, you just, I suppose, you could maybe create your own calculator for this, but typically you go to I suppose a third party that have a verified system for this and use their tool to calculate it. You would then get another party to actually verify your actual EPD. That process is I suppose until you have all the information gathered, can be quite drawn out, because it is a painstaking thing. It's excellent to see how far and in depth you have to go, and the amount of information that's needed. And I suppose this is something that people may believe is just there and it's ready to go. No, there's a lot of information that's going to have to be gathered. It's going to have to be put together. It's going to have to be verified in order to get it finally over the line and produce these EPDs. I think it's something that industries, designers, specifiers will have to, I suppose, start asking for. You might not get them straight away, but it's something that you should want to see industry, the producers, that this is the way they're going to go. And I suppose that's the way we're looking at it now. As part of the life cycle assessment, you know, you're taken into a couple of different phases for typical construction products, because, you know, you can't really take part in the actual project end of things. So we're looking at usually that the phases are sections A, C, and D, which is the product stage, how you produce it and the raw materials that go into it, the end of life stage, and even you know, benefits from the materials themselves, which will be reuse, recovery, recycling potential. And that's one good thing about asphalt. You know, we've mentioned that asphalt is 100% recyclable. It can be reused 100% back into new hot mix asphalt materials. You get a very large carbon saving. You know, you recover a large percentage of it, and that will have a big input into the EPD, how the material performs for that life cycle analysis, when you can either at the very start say, I have a large recycled content in it, and that will improve the overall EPD, or that at the end of it you say, well, this is a recyclable, reusable product. It will, you know, at the end of its life, take on a new life in the same product again with the same life expectancy. So it has a huge potential to, I suppose, provide a good EPD for asphalt materials and show just how sustainable they can be. And of course, if you include on that then warm mix materials with the use of RAP, you know, again, you get another improvement in what the outcome of your EPD and life cycle analysis will be. Okay, that's the end of my presentation.